Welcome to our physics class today. Physics moment. Moment of force. What is a moment? In mathematics, in physics, moment is given by the formula force multiplied by the distance. Force multiplied by the distance will give the moment. And the force, what is the unit of the force? The unit of force is Newton. And the unit of the distance is meter. So the unit of the moment will be Newton meter. So Newton meter or meter Newton is exactly the same thing. And the moment is a scalar quantity. It's not a vector quantity. That means it doesn't have a direction. It has only a magnitude. That is why it is a scalar quantity. Now, we say that the formula to get the moment of force is force multiplied by the distance. When we have a door, this is like a door, and we have the handle of the door here where we put your hand there to open, and then the door will move, go to the left or to right. So the force that I apply on the handle is the force that we have here, the formula. And the distance from here to there, from where the door is turning, so the distance here to there is the distance that we have to use there. Now, before starting the solution, before starting to solve the problem that we have on the board, I need to remind you the conditions of equilibrium. Condition of equilibrium. To have equilibrium, we have two conditions. We have two conditions. What are they? The first is that the sum of the forces in any directions, so the sum of the forces in any direction is equal to the sum of the force in the opposite direction. I repeat, the first condition is that the sum of the forces in any direction is equal to the sum of the forces in the opposite direction. This is the first condition. The second condition is that the sum of the moment about any point is equal to 0. The sum of the moment about any point is equal to 0. This is the second condition. Now that we know the condition of equilibrium, we have the question that is on the board: a uniform meter rule pivoted at the 60 centimeter mark is kept horizontal by placing a 50 gram mass on the 80 centimeter mark. Calculate the mass of the meter rule. Okay. So here we need to know what is the sum of the clockwise moment, so clockwise moment and anti-clockwise moment. Okay. Clockwise moment we have the mass that we have there. We have the mass. So the mass is 50 grams. We need to convert the 50 grams into kilograms. Okay? 50 grams, so the mass, 50 grams, this will give 0.050 kilograms. Okay? 0.050 kilograms. And now, to get the force, what we do, mass multiplied by the gravity. Mass multiplied by acceleration due to the gravity. So mass multiplied by acceleration due to the gravity will give us the force. Okay, so I'm going to write, so force is equal to what? Is equal to mass, that is 0.050 multiplied by acceleration due to the gravity. G is 9.8. So now I take my calculator. I'm going to take my calculator. Now 0.050 multiplied by 9.8, and this will give 0.49 Newton. 0.49 Newton. Okay, we have 0.49 Newton. So this is the force, or the weight, because the weight is a force. Now, this weight here, so because it will go this way, okay, it's going clockwise. So the clockwise moment, we're going to calculate now the clockwise moment. Clockwise moment we give what? Clockwise moment is force. So force is 0.49 multiplied by the distance. The distance is from here, from 60 to 80. 60 to 80. Okay? 60 to 80. Now, if we take 60 to 60, from 60 to 80 centimeter. Now that was now if this was I think this was meters or centimeter. What was the question? It was a meter or centimeter. I just double check. Centimeter. It was a centimeter. Yes, centimeter. So from 60 to 80 is the difference. 80 take away 60. What is the difference? The difference is 20. Okay, so we can convert this in meters. So it should be 80 centimeter is what? Is 0.8 meter, 0.80 meters. Take away 0.60 meters. Okay, now centimeter, sorry. Yes, meter. We convert it into meters. Now, the difference we do what we get, the difference, we get 0.20. 0.20 is the difference. So we multiply now. Clockwise moment will be 0.49 multiplied by 0.20. So then what we are going to get, 0.49 multiplied by 0.20. So I go to get 0.098 Newton meter. Okay, Newton meter. So this is the clockwise moment. Clockwise moment. Now the anti-clockwise moment. Anti-clock. So we are going to calculate the anti-clockwise. To get the anti-clockwise, so is the gravity, okay? So we are it is the mass. I mean the mass of the meter stick. The mass of the meter stick. What we are looking for is the weight. So I put weight. The weight of the meter stick multiplied by weight of the meter stick multiplied by the distance here to there. So the distance here to there, what will be the distance? So from here is 60, okay, because they say it is uniform for 60 centimeter to 50 centimeter to 60 centimeter. The difference is 10 centimeter. 10 centimeter. 10 centimeter is 0.1 meters. Okay, so we have W multiplied by 0.10 meters. Now, clockwise moment has to be equal to anti-clockwise moment. So, anti-clockwise moment has to be equal to clockwise moment. Is what we are going to do now. So, I'm going to write here, we get 0.09. So, 0. So, clockwise, so 0 multiplied by 0.1 has to be equal to 0.098. Okay, so W, what we are looking for, will be equal to 0.098 divided by 0.10. Okay, so we can calculate it. Now we have 0.098 divided by 0.1. So this will give what? This will give us 0.98 Newton. 0.98 Newton is what we get. 0.98 Newton is the weight of the meter stick. Because this is the weight, we need to calculate the mass. Calculate the mass. So we're going to calculate the mass. Mass, we know that the force or the weight is equal to mass multiplied by the gravity. So that means if this is the weight, now the mass will be weight divided by gravity. So mass will be weight divided by G. So that means 0.98 divided by 9.8. Okay, so if we do so, we get what? 0.98 divided by 9.8. So this will give what? This will give 0. The mass is 0.1 kilogram. So mass is 0.1 kilogram. I'm finished. Okay, 0.1 kilogram. So we finish here. Thank you very much.